Hi everybody, in this video we're going to talk about the inverse trigonometric functions. First, just a little bit about notation, which means how we write things. This is how the inverse trigonometric functions are written. This is inverse sine, inverse cosine, inverse tangent. Notice that the -1 is between the sine and where I've written x over here. Okay, now these inverse functions are also sometimes written like this: arc sine, arc cosine, arc tangent. So arc sine of x means exactly the same thing as the inverse sine of x, and same with these and these over here. Now, the reason the inverse trigonometric functions are sometimes called arc sine, arc cosine, etc., is because when we use the inverse functions, we're looking for an angle measure. And when we measure angles in radians, then for a unit circle, the measure of the angle would be the same as the measure of arc, which is traced out by that angle. You really don't have to know that for the rest of what we're going to do here, but just wanted to let you know that's why it's written that way. Now, these are the same. So inverse sine, inverse cosine, inverse tangent are the same as arc sine, arc cosine, arc tangent. But I do not want you to get these confused with these down here, even though they look very similar with how they're written. So do not get the inverse functions confused with the reciprocal functions. So if we write sine x like this, and then outside of the whole thing, we put an exponent of -1, then that's just like what you've been learning about with negative exponents. So for example, 6 to the -1st power would be the same thing as 1 over 6. So the sine function to the -1st power is the same thing as 1 over sine. And if we just replace sine with, remember, sine means opposite over adjacent. So if I have, I'll write it over here. If I have 1 over opposite over, sorry, did I say opposite over adjacent? I meant opposite over hypotenuse. Then I could do keep, change, flip, and then I would flip this as and write it as hypotenuse over opposite, and I could put this over 1. And then 1 times hypotenuse would just be hypotenuse, and 1 times opposite. Okay, anything times 1 is just itself. Okay, so having 1 over sine, it sort of flips the definition. So the definition of sine is opposite over hypotenuse. If we have 1 over sine, then we get hypotenuse over opposite. Same with this over here. Cosine x to the -1st power means 1 over cosine x. So cosine x itself means adjacent over hypotenuse. If we flip that, we would get hypotenuse over adjacent. Tangent means opposite over adjacent. If we flip it, we get adjacent over opposite. Okay, but the point is, actually this video is not really about this, but the point is that these are not the same as these over here, okay? So these are the same as these, but none of this is the same as what I've written over here. So you have to be very careful. That -1 being written outside of everything tells you that you're dealing with a reciprocal function, whereas writing the -1 sort of in between the sine and where I've written x here, or the cosine and where I've written the x, writing it in between there tells us that we're talking about the inverse function. Okay, I didn't even talk about what an inverse function is yet, but I just don't want you to get confused with the notation. These, by the way, are sometimes written like this. Okay, so 1 over sine, or sine to the -1st power, is sometimes written as cosecant. So this is pronounced, or this is the abbreviation for cosecant. And 1 over cosine is written as secant. So that itself is confusing. You would think that 1 over cosine would be cosecant and 1 over sine would be secant, but actually, whoever made this up, I don't know who it was. did it in the most confusing way possible. So you just have to remember that 1 over cosine is actually secant and 1 over sine is cosecant. 1 over tangent, that kind of makes sense. That's cotangent. Okay, so these are the same as these. And again, these are the same as these, but these are not the same as these. So that's just a little bit of notation. We still haven't talked about what an inverse function actually is. So let's do that next. We'll start with inverse sine, but they're all defined similarly. So the inverse sine of x, written this way, inverse sine of x, just means the angle that would give us a result of x when we take its sine. You can make a similar statement for the inverse cosine of x and the inverse tangent of x. All right, so for these functions, we're putting a number in and getting an angle measure out. All right, so let's do an example and that'll make a little bit more sense. So first of all, let's just go back to the ordinary sine function. What happens with the ordinary sine function? What would I put in here? I would put an angle measure in here. So let's say I wanted to find the sine of 30 degrees. I would put that angle measure in here. And what I want out of this is just some number, right? How do I find that number? If I have a unit circle here, then I could take this line here and bring it up to 30 degrees. Okay, you can see it's going through 30 degrees there. So I just made a 30-degree angle with the x-axis. And for sine, we would look at the y coordinate. So this line is intersecting with the circle right over here, and the y coordinate of that point of intersection is 0.5. Okay, so there's an example of using the normal sine function. We put an angle in, we get a number out. Now, what if I wanted to find the inverse sine of something, which would be written this way? In this case, what I'm going to put in here is just a normal number, and then I'm going to ask myself, what angle measure would give me that number if I were to take the sine of that angle? Okay, so what if I put a 0.5 in here? Then the question I'm asking is, the sine of what angle is 0.5? Well, we just did that, so you already know the sine of 30 degrees is 0.5. So the inverse sine of 0.5 is 30 degrees. All right, let's do another example. This time we'll do inverse cosine, and I'm not going to make it so easy for you this time. I'm not going to do an example that makes the next example super easy. I'm just going to start with inverse cosine, and let's make it a negative number. We'll make it negative 0.5. Okay, so what's the question that I'm asking here? The question that I'm asking is, the cosine, just normal cosine now, the cosine of what angle is negative 0.5? Okay, so what we're going to do is we're going to take our line here. Oop, come on. Okay, and remember that when we talk about the cosine of an angle, then we look at where the line meets the circle. So let's say I started over here. The line intersects with the circle right over here. And when I'm talking about the cosine of this angle, in this case, the angle is 0 degrees, I'm talking about the x value of the point where this line meets the circle. So this point right over here is, this point over here is 1, 0. So the cosine of 0 degrees is 1, because that's the x value of the point where this line meets the circle. What we want is negative 0.5. We don't want 1. So this is the wrong answer. If we said that the inverse cosine of negative 0.5 If we guessed that the answer was 0 degrees, well, we would just be incorrect because the cosine of 0 degrees is not negative 0.5. So that's wrong. Let's just keep looking. Now, if we take this, let's bring it around a little bit more. What if I were to stop here? And then I would just draw a dotted line down to the x-axis. Do I get negative 0.5? No. Let's keep going. Just going to keep moving this until I get, did I get it? If I draw a dotted line down to the x-axis, then I see that the x-coordinate of this point is 0. Oh, wait a minute. We didn't want 0.5. We wanted negative 0.5. Still no good. We have to keep going. Let's see. Say stop when you think I've got it. Did you say stop? Yeah, so at right over here, where this line crosses the circle here, if we were to draw a dotted line down to here, we can see that the x-coordinate of this point would be negative 0.5. Okay, we don't even have to worry about the y-coordinate. We're doing inverse cosine, so we're only interested in the x-coordinate. If we were doing inverse sine, we would be interested in the y-coordinate. So it looks like we have our answer here. We just need to figure out what this angle is. And this angle is, I'm just going to tell you, this is 120 degrees. Okay, so the inverse cosine of negative 0.5 is 120 degrees. Again, when we're using these inverse functions, we put a number in, we get an angle measure out, as opposed to doing the normal sine, cosine, and tangent functions, the normal trigonometric functions. We put an angle measure in, we get just a normal number out. Okay, let's do one more example. How about the inverse tangent of 1? So here's the question that we're asking. The tangent of what angle is equal to 1? That's going to be our answer. We find that angle whose tangent is equal to 1. Now, how are we going to find that? It's not as simple as finding just the y value or the x value, like for the inverse sine and inverse cosine. Because for tangent, remember to find the tangent, just normal tangent now, of an angle, we have to divide the y-coordinate by the x-coordinate. So we have to take both of them into account for this. So how are we going to do that? Well, we know that any number divided by itself is 1, right? So for example, 3 divided by 3 is 1. 7 divided by 7 is 1. So what we have to find here is we have to find some angle where the y-coordinate is the same as the x-coordinate. Because then if we divide the y-coordinate by the x-coordinate, we would get exactly 1. And, I didn't make that very hard for you to guess because I kind of landed right on it. So yeah, here at exactly 45 degrees, the line would intersect the circle right over here, and the x value would be exactly the same as the y value. In both cases, it would be approximately 0.7. Not exactly, but approximately 0.7. Okay, so they're both the same there, and therefore when we divide the y-coordinate by the x-coordinate, we would get 1. All right, so the inverse tangent of 1 is 45 degrees. Don't forget that the answer for these inverse functions should be an angle measure. Okay, what's the next thing that we're going to talk about? Aha. Oh no! There are look at that. Oh no, I don't know how to write a sentence. Oh no, there are an infinite number of outputs for each input of the inverse trigonometric functions. Okay, so you probably might not even be, maybe you don't even realize what the oh no is all about. What's the problem? We just did a bunch of examples. We were able to find the answer. It looks like everything is going smoothly, but actually there is a problem because 30 degrees, for example, is not the only angle measure whose sine is 0.5. Can you think of what another one would be? Pause the video, try thinking of what other angle would give us, just like over here. Okay, when we go through 30 degrees here, then the y value, the y coordinate, is 0.5. For what other angle? What angle other than the 30 degrees over here would we get a y value of 0.5? So pause the video and see if you can find it. Okay, so we could take this and move it around until we got over here. And then this, the y value of this point is also 0.5. So what point is that? That would actually be, let's see, 150 degrees. All right, from here all the way around to here, should probably erase this now. From here all the way around to here is 150 degrees. Okay? And there's actually another answer. There's an infinite number of answers, really. Can you find another angle such that when we take the sine of that angle, we get 0.5? So the y coordinate of the point where the line meets the circle would be 0.5. Pause the video, see if you can think of it. All right, did you try it? Well, let's see. Let me keep moving this around. That's not 0.5. No, over here, that would be negative 0.5. That's no good. That's not what we're looking for. We're looking for 0.5. Over here, this again is negative 0.5. No good. And aha, right over here, the y coordinate is 0.5. So we found another one. Now you're probably thinking, wait a minute, Mr. Friedman, that's not another one. That's the same one you showed us before. That's the first one you showed us. That's 30 degrees. No, that's not 30 degrees. Because I just went around the entire circle, which is 360 degrees, and then I went an extra 30 degrees more. So how far did I go all together? I went 360 plus 30, which is 390 degrees. Can you find another one? This one over here, that's not 150 degrees again. That's 150 degrees plus the 360 from going all the way around, which, let's see, 150 plus 360. 350 plus 150 would be 500, so that would be 510, right? Hope I got that right. All right, and you're probably getting, you see the idea here is we could just keep going around and around these circles, and oh, look, I found another one, and another one, ooh, and another one, and another one, ooh, and another one, and another, okay. You get the idea, right? So actually, the inverse sine of 0.5 is going to have an infinite number of outputs. And that's why I put function here in quotes almost sarcastically, because what's the definition of a function? Something that for each input only has one output. We don't want We don't want an infinite number of outputs. 2 outputs is bad enough. What we have here is an infinite number of outputs, right? An infinite number of angle measures that give us an answer of 0.5. So that's a problem. And that means that the inverse trigonometric functions, we could do the same thing with inverse cosine and inverse tangent. They're not actually true functions because there's an infinite number of outputs for each input, because we can just keep going around the circle as many times as we want. In fact, I didn't have to go up this way. I could have started here and gone backwards this way, and then I would be finding a bunch of, right, clockwise, by the way, is like backwards. Clockwise, these angles would be defined to be negative. So I could go backwards like this, clockwise, and then I would be finding a whole bunch of negative angles whose sine is 0.5. Okay? So not only do we have an infinite number in the positive direction, we would also have an infinite number in the negative direction. So these inverse functions are very far from being actual functions. They're not functions, okay, because there is more than one output for each input. But we can change the definition of what they mean and change the answers that we'll accept to turn them into functions, okay? So in order for them to be true functions, we can restrict the outputs to the smallest absolute value. This is called the principal value. So going back to this example over here, I'll just stick with this example. Instead of saying that inverse sine has of 0.5 has an infinite number of angle measures, we're just going to say, okay, you know what? I'm not even going to accept these. I'm just going to look for the smallest one, okay, or the one with the smallest absolute value. Well, there can only be one smallest number, right? And in this case, it would be 30 degrees. So this would be called the principal value. And when you use a calculator to find the inverse sine or cosine or tangent of some number, then the calculator is going to give you, most likely, I mean, it depends on how it's programmed, but most likely it will just give you the principal value, meaning the number with the smallest absolute value that gives us this number back. Okay, let's do another example of finding the principal value for the inverse of something. Let's do the inverse sine of -1. So we're looking for an angle measure such that when we take the sine of that angle, we get -1. So what angle measure would have a y-coordinate of -1 where the line here meets the circle? All right, so over here, if you look at this right over here, this point is the point 0, -1. Okay, so that matches the description that we wanted, right? Now because the y value is -1. Now what angle is this? So we started here and then we went clockwise over to here. This would be -90 degrees. I'm going to write that over here because I'm going to leave some room for some other possibilities. So we know, whoops, forgot the degrees. So -90 degrees works, but there are other numbers that also work. So I could just take this line and go around another 360 degrees, and that would bring me back where I started. So 360 plus 90 would be 450, except I went clockwise. I went in the negative direction. So another possible answer here is negative 450 degrees. Now, I didn't have to go in the negative direction to get here. I could have gone in the positive direction. So starting from here, I could have gone around in the counterclockwise direction, which is positive, could have gone 270 degrees. Okay, from here around here like that, that's 270 degrees. You can see that it says 270 degrees right over there. So that's another possible answer. Now, my principal value is going to be the number with the smallest absolute value. Now, the smallest number here that I've written is negative 450. Negative 450 is less than negative 90 and is also less than positive 270, of course. So out of the three numbers that I wrote, negative 450 is the smallest one, but it is not the number with the smallest absolute value. The absolute value of negative 450 is 450. The absolute value of negative 90 is 90. The absolute value of 270 is 270. So the number that I've written here that has the smallest absolute value is actually negative 90. And that is the principal value here. There's no other number, there's no other angle measure whose sign is negative 1 that has a smaller absolute value than negative 90. So we could find an infinite number of answers. So I could just keep going around this way. And if this was negative 450 degrees, I could go backwards 360 degrees again, and I could find another answer, and that would be what? Negative 810 degrees. Okay, because 450 plus 360 is 810, but I was going in the negative direction, so negative 810 degrees. So I found another angle measure, and negative 810 is even smaller than negative 450, but we're not talking about the smallest number, okay? Really, we could never get to a smallest number because there would be an infinite number of numbers going in either direction, in this direction and in this direction. So I'm never going to get to a smallest one, but that doesn't matter because we're not talking about the smallest one. We're talking about the number with the smallest absolute value. As we keep rotating this thing clockwise like this, the numbers would be getting smaller and smaller and smaller, but the absolute values would be getting larger and larger and larger. So again, we're not going to find an answer that has a smaller absolute value than negative 90. So negative 90 is the principal value here. So if you were to put the inverse sign of negative 1 into a calculator, it's not going to give you all of those other values, most likely. Again, it depends on how it's programmed. But it would probably give you just one answer of negative 90. So let's go ahead and do that. So I am in the Desmos calculator now. So you can go to desmos.com/scientific. And to switch to the inverse trigonometric functions, you have to click on this button here that says function. And then let's find inverse sine. Okay, so the inverse sine of the example that we were doing was negative 1, right? Okay, the inverse sine of negative 1. Oops. Make sure that you get it in the parentheses there. My answer shows up on this side. Oh, good. Okay. So negative 90, and I had it in degrees. So that's negative 90 degrees. It really should say degrees over here. Okay, because really that is an angle measure. Okay, but you can see that it didn't give me negative 450 degrees or 270 degrees or negative 810 degrees. It only gave me the principal value of negative 90 degrees, even though the sine, so even though the sine of negative 450 degrees is -1, and the sine of -810 degrees is also -1, and the sine of 270 degrees is also -1, and we could go on and on and on. Even though there are a lot of angle measures that give you a sine of -1, -90 is the principal value. Okay, so by choosing only the principal value, then we're actually turning these back into real functions. So by accepting only the principal value and calling that the answer, then we can say that there's only one output for each input. So the inverse trigonometric functions are back to being real functions. Now, what if I had something like this, the inverse cosine of -1? I'm just going to find two possible answers here. Uh-oh, messed that up a little bit. Let's fix that. Okay, so one possibility is 180 degrees. Okay, remember, really, we're starting over here. So I could go around here, and I just made a 180-degree angle. Okay, this point over here is the point -1, 0. So it does have an x value of -1. Okay, so one possibility is 180 degrees. Cosine of 180 degrees is -1. Another possibility is, well, I could have, starting from here, instead of going this way, I could have gone around the other way, clockwise. All right, and I end up in the same place. And in that case, I went clockwise 180 degrees. So I get -180 degrees over here. So, and you could find more examples just by going around the circle however many times you want, right? We could start with 180 degrees, and then from there go around counterclockwise another 360 degrees. So altogether, we've gone 540 degrees. We could do the same thing. Imagine that this is -180 now, and then I could go clockwise another 360 degrees, and then that would bring me down to negative, I kind of ran out of space, but -540 degrees. Okay, but if we keep going around and around and around the circle like that, then the absolute values are increasing, not decreasing. So we don't have to worry about those. These are the two smallest ones. And by smallest, so -180 is technically smaller than 180, but we're talking about the absolute values now. The absolute value of -180 is 180. The absolute value of 180 is 180. So both of these have the same absolute values. Well, what do we do in that case when two possible answers are just as small in terms of their absolute values? Well, in that case, we would just pick the positive one. So if you go to a calculator and you plug in the inverse cosine of -1, it's not going to give you 540. It's not going to give you -540. It's not even going to give you -180, even though the absolute value of this is the same as the absolute value of this. In the case where you have two answers with the same absolute value, it would give you the positive one. So let's go ahead and go to the calculator here, and just to see that, click on functions here, click on inverse cosine. What did we want to do now? Back to main. Inverse cosine of -1, it's going to give us positive 180, not negative 180. All right, so in the case of sort of a tiebreaker where the absolute values are the same, the positive number wins. All right, so again, just like I talked about in the other video, you will be using the calculator most of the time when you're trying to find the inverse sine, inverse cosine, inverse tangent of something, just like you're using a calculator a lot to find the sine or the cosine or the tangent of something. But it's still a good idea to know a few of them, or at least to be able to understand it well enough to be able to figure it out. So let's go ahead and finish the video by doing some examples like that, some simple examples. So the inverse sine of 0. Of course, there would be an infinite number of answers, but we're just looking for the principal value. So what angle measure would give us a sine of 0? So what angle measure would have a y coordinate of 0? That would be 0 degrees right over here. Okay, because this point here has a y value of 0. What angle measure gives us a cosine of 0? So the inverse cosine of 0 means what angle measure gives us a cosine of 0 so that the x value is 0? Well, the x value here is not 0. The x value here is 1. But if we move this over to here, then this point would be the point 0, 1. So it does have an x value of 0, okay? So, and that is 90 degrees. What about the inverse tangent of 0? What angle has a tangent of 0? That would be 0 degrees. And why is that? Because the line meets the circle over here at the point 1, 0. The tangent of 0 degrees would then be 0 divided by 1, the y value divided by the x value. And 0 divided by 1 is 0. Inverse sine of -1. What number has a sine, what angle has a sine of -1? That would be -90 degrees. Okay, we went 90 degrees clockwise to get here, and this point is 0, -1. So it does have a y value of -1. So -90 degrees there. Inverse cosine of -1 means what angle measure has a cosine of -1? This point over here is -1, 0. Okay, and that is 180 degrees. So you saw me move 180 degrees in the clockwise direction, but we were talking about a little earlier that I could also have gotten there by moving in the counterclockwise direction, and we would take positive 180 degrees as the principal value. So we're going to write 180 degrees over here. And you know what? I'm going to just write this point in also. I erased it earlier. So that's the point 0, 1. Yeah, so you know what? That's probably a good idea to figure all of these out. Maybe just write these numbers in first. So for the inverse tangent of -1, we're asking ourselves, what angle has a tangent of -1? Meaning if we were to take the y value and divide by the x value, we would get -1. So let's see, 0 divided by 1, is that -1? No. 1 divided by 0? No, that's undefined. -1 divided by 0? No, that's undefined as well. 0 divided by -1? No, that's 0, no good. So actually, after saying that you should draw these points in, we immediately got an example where it's not any of these points over here. But it would be, just remember earlier we said that the inverse tangent of 1 was 45 degrees, because then the y value is the same as the x value, so when you divide them, you get 1. We can use very similar reasoning for the inverse tangent of -1. And right over here, that's where we would get a tangent of -1. Okay, so what point is that? that is approximately, I keep writing commas for some reason whenever I want to write 0.7. So that's approximately 0.7, negative 0.7. 0.7 on the x-axis, negative 0.7 just about on the y-axis. Okay, and if we do this divided by this, then we do get negative 1. Now, we would not use 315 degrees. We would not put that as our answer because that's not the principal value. We can find a smaller, that's if we started here and went all the way around this way, then we would get 315 degrees. But you probably realize there's a faster way to get there. If we start here, then we could just go clockwise by 45 degrees, which really means negative 45 degrees, and that would be our principal value. So the inverse tangent of negative 1 is negative 45 degrees. Now, actually, there is another angle here, which gives us, or really another place that I could move this line here, which gives us negative 1 again, and it's right over there. So if we go to 135 degrees, this point, I think we were saying that in another video, we would get about negative 0.7, 0.7, and this divided by this would also be negative 1. But negative 45 degrees has an absolute value of 45. 45 is smaller than 135. So this would still be the principal value. And if we were to go to a calculator here and try to find the inverse tangent of 45 degrees, oops, sorry, the inverse, I got scared there for a second. We don't want the inverse tangent of 45 degrees. Okay, we want the inverse tangent of negative 1. It will give us an answer of negative 45 degrees, not 135 degrees, because the absolute value of negative 45 is smaller than the absolute value of 135. Okay, let's continue with these over here. So what angle has a sine of 1? That would be this right over here, and that's 90 degrees, has a y value of 1. Let's see, what angle has a cosine of 1? That would be 0 degrees. Okay, because the x value is 1. When we're talking about sine, we're talking about the y value. When we have cosine, we're talking about the x value. And finally, what angle measure has a tangent of 1? So the inverse tangent of 1 means what angle value has a tangent of 1? And we already talked about that. That was 45 degrees, because we would be doing 0.7 divided by 0.7. Okay, so for most times that you're finding the inverse sine or inverse cosine or inverse tangent of something, you will be using a calculator. But it's good to be able to do some easy ones on your own just by thinking of a circle and doing exactly what we just did. Okay, so I'm going to end the video there, and have a great day.